Today we are going to see about phototransistor experiment. Here we will be studying the VI characteristics of phototransistors. So here in this experiment, this is the circuit diagram wherein this is our transistor which is connected parallel to voltmeter, and then the positive side of the voltmeter is connected to ammeter, and then ammeter's positive side is connected to the source input. Here it is DC input, which is from 0 to 5 volt. So this is a simple circuit. So we'll start with the procedure. Now this is a given setup wherein this is our laser source and this is our polarizing material, and this one is our phototransistor. So in this setup we will not disturb anything, but make sure that when our source is hitting on this and then falling on our phototransistor, this phototransistor should reflect back the light right on top of this. So in simple, it should, like the light which is passing from here should go again hit back this. So this is a circuit diagram and we are connecting it in the same format wherein we saw that this is our negative of phototransistor and this is a positive of phototransistor, which is connected to our voltmeter, and then from voltmeter's positive it goes to negative of ammeter. So the same thing is happening. So from positive it's coming here to the negative point, and then voltmeter's negative side is going to the input source. So voltmeter's negative is going here to input source negative side. So negative to negative, here from positive to negative. Then the left out part is the positive side of the input and the positive side of the ammeter. So we'll connect both of them. So this is a simple circuit connection. Now for the initial adjustments, we'll have a voltage to be 3 volt, and then for a polarizing thing, here we will rotate this, the one which is perpendicular to the source. So this part we will be rotating. While rotating, our current values will be increasing or decreasing. If it's decreasing, rotate it the other way. So when you rotate, when your values start increasing, keep on rotating it until you get the maximum ammeter reading. So now here our maximum values 7.1, 2, 3, 5 and 6. So after 6 it's reducing, so we have to stop it there itself. So 47.5 is our maximum current value. So we'll stop it there, and then now our work was with this. Now we'll check our reading here. Now here we have a white line here. This we should align with 0. So we will rotate this, rotate it and align it with 0. After aligning, this is our initial adjustment. After this we will not be touching this thing. Our every value and every reading will be taken after rotating this. So any angles will be taken there. We'll be taking 0 degree, 25 degree and 50 degree. So to get to those values, we will rotate this in such a way that here we'll get the reading to be as 25 or 50. And then we will now to further proceed with our experiment. After the initial adjustments, we will be setting the voltage to be as the given voltages here, and then we'll be taking corresponding readings of current for milliampere. So then these readings will be getting for corresponding thetas. I've told you how to set them. So after setting them for each trial, you'll be taking different voltages and note down the reading for currents. So after the current, after you note down the current readings, you'll get a graph in such a way. This is a model graph given for the different theta values. Here the theta values are 0, 50 and 60, but here we are taking readings for 0, 25 and 50. So here the first the uppermost, the higher graph, the higher curve is for 0, and this is for 50 and this is 60. So in the same way, Here also when the theta increases, the graph values will be decreasing. Now here for the second part of the experiment, here we will be setting our voltage constant, which is 4.6. It will depend on the given setup. Usually we'll take 5 volt, but here it was maximum was 4.6, so you can take the maximum value for the voltage, and then we'll be adjusting the theta values and taking down the current readings. So current readings will vary according to the graph given here. It will have a peak value and then it will drop, again get to a peak value, again drop and peak value. This is how even your values you will be getting. Now this is the graph drawn for the first curve. In this, this curve is for theta is equals to 0, and the next one, which is really close to 0, is 25, and then the lower one is for 50. So you will plot it and then write your scale. And then this is for the second part of our experiment, wherein we take our x-axis to be as theta and this one to be as our current, and you will be having 3 peaks, and this should not change, and then it will have 2 drops, and it should be similar to the given model graph. So the result for this experiment is we are verifying the VI characteristics, and we have no more calculations left out, only just the graph and the plotting things. That's it.